Hello and welcome to Hemlock Explains. Today I'll be talking about the TCP IP model. And if you watched the last video, we went over the OSI model. And so the TCP IP model is different because it came later than the OSI model, and we'll see a couple differences, but there are a lot of similarities. So what is the TCP IP model? Just like the OSI model, it's a model or a framework for thinking about traffic. So let's go back to that example we used when we talked about the OSI model. What if a customer says, "Why isn't your website working?" Again, you could start by looking at all of the ones and zeros that have gone in and out of your customer's network in the past day or your own network. Or you could start by investigating, in this case, the 4 layers, because the TCP IP model has 4 layers rather than 7 layers, that might be acting up. And so this is just a way that you can kind of conceptualize network traffic, internet traffic, and how a computer handles something coming from the internet. And so this was our OSI model. And now let's look at the TCP IP model. Okay, so you see there are some similarities. You'll see that each of these will have an application layer. So one of the first similarities, if you remember our example from last time, we had a server, and this server hosted cat pictures. And we said that if someone is over here and they're on a computer and they want to look up a picture on the server, basically that information will travel down the layers in both the OSI model and the TCP IP model, and then over some magical thing that we'll just say is the internet. And then when it gets to the cat server, it will go back up these layers again. So first, let's talk about the network access layer, or the application layer. Let's start up here. Let's start with the highest one. The application layer is exactly like the application layer in the OSI model, and this is the actual applications that are handling something on your computer. So this could be like Chrome or Outlook, and it's the exact same thing as the application layer in the OSI model. So now let's talk about the transport layer. The transport layer kind of corresponds to layers 4, 5, and 6 of the OSI model. And so this handles things like organizing data into packets, like we talked about in the OSI model video. So it breaks things down into 1,500 byte chunks. And these packets, it also does a lot of other things, like the transport layer might give some information on how, if let's say the cat server sends back 30,000 packets for a cat picture, and then you get that on your computer, what it will also send along with this 30,000 is metadata. And that will kind of describe how this data should be reorganized when it gets back to your computer. And because imagine if you get the cat server will divide up this traffic into 30,000 different packets, and with those packets it will send some metadata on how when your computer gets it, these packets should be organized. So some information so that you can do some error checking and make sure that you reassemble them in the best way. Because imagine if on your server you get the 5,007th packet first. Well, that might be, that might make it so that if you organize that as the first packet, the cat's toe or something is in the top left-hand corner, and the picture just wouldn't make sense. And so you have some metadata on the transport layer that's kind of helping explain how to reorganize all these packets. Now, after this, you have the internet access layer. And the internet access layer is going to mostly be concerned with things like IP addressing and routing. So again, this is for wide access networks. And then and this will correspond to layer 3 of the OSI model. I'll actually write all that out at the end. So let's say let's go over the network access layer, and then we'll talk about which these correspond to. So the network access layer is going to be MAC addressing and the physical aspects of transportation. So this might be, cable or information or some kind of signal, some kind of Wi-Fi signal that's sent to your device. And so let's look at how these correspond to the OSI model. So for the OSI model, the application layer is the same in both. It's the top layer. It's Google Chrome, it's Microsoft Outlook, something like that. The transport layer, this is going to be layers 4, 5, and 6. And then the internet access layer is going to be layer 3 of the OSI model, and then the network access layer is going to correspond with layers 1 and 2 of the OSI model. And so that's how that's how these two connect. And so the TCP/IP layer, the TCP/IP model is more, is smaller. And remember how we talked about the OSI model came out in the 70s? And so sometimes you might have trouble explaining for these 4, 5, and 6 layers of the OSI model which one it exactly fits into, especially with like the presentation layer. Our understanding of computers and how we use computers have changed since the 70s, and so the TCP/IP model is a little bit more accurate. So yeah, why isn't your website working? Well, we can look back at, we can just go through a series of elimination and say, okay, if the computer is physically connected to a wire and with its MAC address it's able to reach the router, it's not a layer 1 problem of the TCP/IP model. If we're actually hitting the right IP address, it's not a layer 2 problem. If the packets are, divided properly, things like that, it's not a layer 3 problem. And then we can look at, the server application or your Google Chrome application, determine if it's a layer 4 problem. So that's how this model is useful. Just like the OSI model, it kind of gives you a framework for understanding how to think about traffic. Okay, so that's all I have for the TCP/IP model. This was Hemlock Explains.